Okay, this lesson is on right triangle trigonometry. The picture shows a fireman on a ladder. He's trying to reach the top of the building. The question is the fireman's ladder tall enough to reach the top of the house? Um, we're going to go over using some mathematics how to determine whether his ladder is long enough. We're going to look at the angle of the ladder, the length of the ladder. This ladder does extend farther than it looks in the picture, and if you just want to copy down some of these examples, we'll learn how to figure out this question. All right, so first off, a quick review of right triangle trigonometry. We're going to be looking at finding the missing sides, but we first need to know the three identities for cosine, sine, and tangent. I'm going to write the one for cosine first. So cosine of an angle, we'll call the angle x, always equals the adjacent side over the hypotenuse. Next we have sine. Remember it's abbreviated SIN. Sine of an angle, x, is always the opposite side over the hypotenuse. And last, the tangent of an angle is always the opposite side over the adjacent. Now remember, these all are referring to right triangles. So we have our little 9-degree angle in the corner there. If we called the bottom right angle x, then our opposite side would be directly across the triangle from x. Our adjacent side would be directly next to x. And then our hypotenuse would be the third side, the longest side across from the 9-degree angle. All right, so this is our basic right triangle trigonometry. We use these three equations to solve situations, and I'm going to show you 5 examples on the previous pages. Write down each example, and then we'll take the time to do some practice problems. All right, the first example is using tangent to find x. Now, we have to remember what tangent is. So first off, we just wrote this down, but tangent of x. I'm going to change that x actually. Let's change the x to our angle. All right, so our angle, we'll just use theta as our angle. It always equals the opposite side over the adjacent. So in this case, in this triangle, our angle is going to be our 43 degrees, right? Written up here in the corner. And our opposite of that 43 degrees is going to be our x. And our adjacent side to that will be our 12. Okay, so we have our tangent equation here. Now to solve this equation, we're going to solve it like any other equation. We have tangent 43 equals x divided by 12. In order to get x by itself, we're going to times both sides by 12. And we end up with 12 tangent 43 equals x. All right, now this spot, we can just put 12 tangent 43 into our calculator. If you do put that into your calculator, you end up with approximately 11.2. Right, so 12 times tangent 43 equals 11.2. So that means x is 11.2. And that's our first example. That's our example 1. Let's take a look at another example. All right, in this example, we're going to be using sine. And we're going to be using sine to find x. Now, first off, the way that I know that we're going to use sine, besides that it's written right here, is that we are actually given the hypotenuse, which is here. Right, we're also given the opposite of this angle, 28, right? Opposite is across from the angle 28, right? This is the adjacent side. The 28 goes where that arrow is pointing. So we have the hypotenuse, we have the opposite side. Since we're using those two things, we're going to use sine, because sine of an angle, which I'm going to write as theta, equals the opposite over the hypotenuse. Right? So when we go to solve this, we're going to write sine of our angle that they gave us, 28, equals the opposite, which in this case is just x, over the hypotenuse, 15. Now we have an equation again, which we can solve. We're going to do exactly the same thing we did last time. With tangent, we're going to times both sides by 15. Right? And in doing so, we end up with 15 times sine 28 equals x. And again, you can take a second, put this into your calculator. And if you should end up with just over 7.04. And that's what x equals. So that's about what you should have gotten. Again, we're rounding. It doesn't have to be exact. All right, third example. All right, for this one, we're going to be doing the exact same thing we did on the previous one. We're going to be using cosine to find x. So we're going to set it up the same way. And I know we're going to use cosine. It says it here. But also, because we have the adjacent side and we have the hypotenuse. Right, we're trying to find the adjacent side. It's x. We're given the hypotenuse, so we can set up our equation for cosine. Remember, it's adjacent over hypotenuse. So plugging in our values in our triangle, we end up with cosine of our angle 58 equals our adjacent side x over our hypotenuse 18. And again, we're going to solve it like the two previous examples. Times both sides by 18. We end up having 18 times cosine 58 equals our x. And again, you can punch this into your calculator. 18 times cosine 58. And you should get approximately 9.5. So x equals right around 9.5. So that's our value. That's the length of that missing side of the right triangle. All right, the next example. This example is somewhat different than the previous ones. First, I'm going to identify what I have. So I have the adjacent side is not given. It's down here. We don't know what that is. We know that the opposite side, right across from here, from our angle, the opposite side is 12. All right, we also are looking for the hypotenuse. We don't know that. So if we have the we're looking for the hypotenuse, We know the opposite side. We're going to use sine, right? Because sine of an angle equals 12 in this case over the hypotenuse x. Now our angle, I could have plugged that in. Our angle is 40. It says it in our problem right inside our triangle. We end up with 12 over x. Now this is different than the previous ones because the previous ones our x was on the top. But in this one our x is on the bottom of our fraction. So in order to solve this one, our first step is going to be to get that x and move it to the top of the fraction. And by doing that, we're going to have to multiply both sides by x. So I times by x on both sides. That cancels the x's on the right side of the equation. We end up with x times sine 40 equals 12. Now, in order to finish solving this problem to get x by itself, we're going to have to divide by that sine 40 on both sides. So from the previous examples, we ended up multiplying our two values together. This time we're ended up dividing. We're going to take 12 in our calculator, divide it by sine 40. We should end up with our answer. Roughly around 18.7. All right, so you should have gotten for an answer there about 18.7. All right, last example, very similar to this one. We end up having to use cosine to find the hypotenuse. Now again, we know it's cosine because we're looking for the hypotenuse. We have the adjacent side. So our only trig identity that uses an angle with the adjacent side over the hypotenuse is cosine. And so we end up taking our cosine of our 40-degree angle. That's equal to the adjacent side, which is 6, over our missing side, the hypotenuse of x. We can do the same thing to solve this one as we did on the previous example. Start by multiplying both sides by x. We end up canceling x on the right side. X times cosine 40 equals 6. And then the last step is to divide both sides by cosine 40. And x will equal whatever 6 divided by cosine 40 is. You can put that directly into your calculator. You get right around 7.8. All right, and those are our examples. Hopefully you took these notes and you can use them for the assignment.